Welcome to the channel. Today we will be solving LeetCode problem 339 nested list weight sum. Let's go over the question. You are given a nested list of integers. Each element is either an integer or a list whose elements may also be integers or other list. The depth of an integer is the number of lists that it is inside of. We need to return the sum of each integer in nested list multiplied by its depth. Let's look at example 1 to understand the question better. This is the nested list and its depth. The output is 10 because when we multiply each element by its depth and then add them up, then we get the answer 10. Let's take this example test case to understand the question better. The expected output of this test case will be 41 because when we add the multiplication of each single integer element to its depth, then we get 41. In this example, the red integer element are at depth 3, blue integer elements are at depth 2, and green integer elements are at depth 1. So now that we understand the question, let's try to think about simplifying the problem. The simplification idea is to visualize inner elements as a graph representation, where each element, whether nested list or integer, will be represented as a graph node. And each nested element, when visualized at a deeper depth, gets unwinded till the point it becomes an integer element. For example, at each depth, the nested brackets are removed. Or we can say that the nested list is getting unwinded at each deeper depth, and that keeps on happening till it becomes an integer. Similarly, next integer element 4 in nested list will be represented as single integer graph node at depth 1. Similarly, next inner element in nested list will be represented as a graph like this. So finally, we have converted the original question to a graph problem. Now the question has simplified. We know that for trees and graph problems, mostly the solutions are DFS and BFS. We will use a BFS to solve this problem. We will start our traversal with root nodes which do not have any incoming edges to it. Those will be our seed nodes where we will start our BFS traversal. Then at depth 1 we will check which elements are single integer. Only element 4 is single integer. So we will multiply it by its depth, which is 1. Then we go to the next depth and check the single integer elements, which are 3, 1 and 4. We multiply each of these elements by their depth and add them all up. We go to next depth 3 and check single integer elements, which are 2 and 5. We multiply each of these elements by their depth and add them all up. Finally, we add all depth intermediate results to get to the final answer 41. Before coding, let's look at the nested integer interface that LeetCode provides. In this interface, we will be using isInteger, which returns true if NestedInteger object is a single integer and does not have any nested elements. We will use getInteger function to get the value of single integer that the NestedInteger object holds. We will use getList to get nested list elements that the NestedInteger object will be holding. These are the only 3 functions that we will be using in our solution. Other functions we can ignore it as they are not relevant to the solution. Let's code the solution up. We will start by adding seed nodes to the queue variable. These seed nodes will be the root nodes without any incoming edges. We will also add their depth as the second element, which will be 1. We will initialize total to 0. We will start our BFS traversal with the while loop. Next, we will pop the current element and its depth from the queue. Now we will check if the current element is integer. If the current element is a single integer, then we will add the multiplication of its value and the depth to the total variable. If it's not a single integer, then we will loop through all the nested elements that it has, and each of these nested elements will be appended to the queue variable. When appending these nested elements, we need to change the depth of these nested elements. They will be at a deeper depth, so we will do depth plus 1. At the end, we will return the total variable. Let's submit the solution. It got accepted. Let's do a complexity analysis of our code. The total time will be O of n because we traverse all the nested elements. Over here, n is number of elements in the nested list array. The total space will be O of n because of the storage taken by the queue variable. In worst case, all the elements of the graph will be at the same depth. Thank you for watching this video and stay tuned.